You have seen the footage 1,000 times by now. A T-72 takes a hit from a drone or a Javelin.
There is a split-second delay, a flash, and then the laws of physics take a vacation.
The turret, weighing 12 tons, is launched 50, sometimes 100 feet into the air.
It spins like a coin. It crashes down through concrete or buries itself in the mud.
Engineers call this catastrophic failure mode the jack-in-the-box effect.
The internet calls it the turret toss, but for the crew inside, it is instantaneous vaporization.
This isn't just a weakness. It is a fundamental feature of Soviet armored architecture.
It is a design choice that prioritizes geometry over human survival.
We need to explain the mechanics of why this happens. It comes down to the autoloader.
The Soviet Doctrine wanted to delete the fourth crew member, the human loader.
Humans are slow. Humans get tired. A mechanical arm can load a 125mm shell in 6 seconds, forever.
By removing the human, they could make the tank smaller, lower profile, harder to hit.
That works great for 1970s ballistics, but it required putting the ammo rack on the floor.
Specifically, a carousel mechanism directly underneath the commander and the gunner's feet.
Imagine sitting on a swivel chair. Now imagine the base of that chair is lined with 40 high-explosive shells.
And not just the shells, the propellant charges. Those are the real killers.
Russian ammo is two-piece. The projectile is separate from the propellant charge.
The propellant is highly volatile. It sits in that carousel, completely unarmored.
In an American M1 Abrams, the ammo is stored in the back of the turret, behind a blast door.
If an Abrams gets hit, the blowout panels vent the explosion upwards and outwards. The crew survives.
In a Russian T-90, there are no blowout panels. The tank is the pressure vessel.
When a shaped charge penetrates the hull, it sprays molten copper into that carousel.
The propellant cooks off. It doesn't just burn, it deflagrates instantly.
The pressure inside the hull spikes to thousands of psi in a fraction of a second.
That pressure needs an exit. The hull is welded tight. The tracks are heavy.
The weak point is the turret ring. The ring shears off completely.
The turret becomes a piston. The hull becomes the cylinder.
It is an internal combustion engine, where the crew compartment is the combustion chamber.
The force is enough to throw 12 tons of steel higher than a 5-story building.
From a logistics standpoint, this is a nightmare. You don't just lose the tank.
A tank can be repaired if the tracks are blown off. It can be fixed if the engine dies.
But when the turret pops, the hull is warped. The electronics are melted. It is a total write-off.
And you lose 3 trained tankers. You can't mass-produce experience.
Yet Russia keeps building them this way. Why? Because it is cheaper.
It's lighter. A T-72 weighs 45 tons. An Abrams weighs 70.
That means Russian tanks can cross bridges that would collapse under NATO armor.
It gives them strategic mobility. They can move faster by rail and by road.
But the cost is paid in blood. They traded armor protection for logistical speed.
They assumed they would have so many tanks that losing a few thousand didn't matter.
Quantity has a quality all its own until you run out of trained crews to man the machines.
Modern anti-tank weapons attack from the top. They hit the thinnest armor,
which puts the warhead directly on a collision course with that ammo carousel.
We are seeing T-80s, T-64s, and even the modern T-90M suffering the exact same fate.
They put a cage on top. They put reactive armor on the sides. That doesn't matter.
Once the spark gets inside, the physics take over. There is no suppression system fast enough to stop it.
It takes milliseconds. The automatic fire extinguishers don't even have time to trigger.
It's a death trap. But understanding the how requires looking at the autoloader mechanism itself.
We need to dissect the Korzina system and the specific placement of the charges.
Let's tear down the mechanical failure that leads to the pop.
And I want to talk about the cost of retrofitting VS, the cost of replacement.
Let's open the hatch. To really understand why this mechanical failure is so consistent, we have to look at the specific architecture of the Korzina automatic loading system found in the T-72 and T-90 series. Unlike a human loader who pulls around from a protected, Rack, the Korzina, is an electromechanical cassette system that sits on the floor of the hull, rotating on a horizontal axis to align the specific projectile and propellant charge with the gun breech before a hydraulic arm rams them up into the barrel. This means that at any given moment, you have roughly 22 ready-to-fire rounds arranged in a radial pattern literally surrounding the legs of the crew, creating a complete ring of high explosives that fills the entire lower diameter of the fighting compartment.
And from a manufacturing and procurement standpoint, this design was hailed as a stroke of genius by Soviet planners because it dramatically simplified the supply chain and reduced the sheer volume of steel required per unit. By eliminating the loader's standing room and compressing the internal volume, they could produce 3 T-72s for the cost of 2 equivalent NATO tanks, essentially flooding the European theater with armor that was good enough for a massive, aggressive push. The problem is that this doctrine relied on the assumption that the tanks would be fighting head-on against other tanks where the thickest frontal armor would protect that volatile ammunition carousel from enemy fire.
That frontal protection is completely irrelevant in a modern battle space dominated by top attack munitions like the NLAW or the Javelin, which are specifically programmed to fly over the tank and detonate a shaped charge downwards into the thinnest part of the turret armor. When that copper jet punches through the roof, it doesn't just kill the crew, it sprays molten metal directly into the cassette mechanism we just described, instantly compromising the semi-combustible casings of the propellant charges. Unlike Western ammunition, which uses a metal casing that offers some resistance to fire, shrapnel, Russian propellant cases are made of a fragile, impregnated cardboard-like material designed to burn up completely inside the gun breeches, meaning they have zero protection against spalling or sparks.
This is where the corruption and failure of the Russian military-industrial complex really shines, because for decades, their solution to this known vulnerability wasn't to redesign the chassis, but to slap upgrade packages on the outside. We've seen internal financial reports indicating that billions of rubles were allocated for advanced explosive reactive armor, or ERAA, specifically designed to break up those incoming warheads before they penetrate. But when you inspect the wreckage on the battlefield, half of those ERAWA bricks are filled with cheap rubber or empty egg cartons, because the high-grade explosives were sold off on the black market by logistics officers looking to buy dakas in the suburbs of Moscow.
Even if the ERA works exactly as advertised, it struggles to stop the kinetic energy transfer that occurs during a side impact or a catastrophic hit to the rear engine deck, which can start a fire that eventually cooks off the ammo storage. Anyway, we call this a loss of containment, and in Western tanks, we use wet storage sleeves, literally water jackets around the ammo, or armored blast doors that separate the crew from the boom. The T-Series tanks have absolutely no internal spall liners or blast partitioning between the autoloader and the commander, meaning the internal pressure wave has a propagation speed faster than the human nervous system can process pain.
Retrofitting these tanks to fix the flaw is economically impossible because the autoloader is integrated into the very suspension and chassis of the vehicle. You would effectively have to gut the entire hull and rebuild it from the ground up. This leaves the Russian Ministry of Defense in a sunk cost fallacy, forcing them to deploy thousands of flawed T-72s and T-80s because their supertank, the T-14 Armata, which actually moves the crew to an isolated armored capsule, is too expensive to produce in meaningful numbers due to Western sanctions on optics and microchips.
So the crews are forced to improvise field modifications that offer almost no improved survivability, like welding cope cages or slats of steel roofing over the turret in a desperate attempt to trigger the fuses of incoming missiles prematurely. While this might stop a basic RPG-7 from the 1980s, it does absolutely nothing against a tandem charge warhead or a kinetic penetrator that enters the turret, turns the crew compartment into a blast furnace, and ignites that propellant ring. Once that chemical reaction starts, the physics dictate that the turret ring bolts, which are designed to hold the weight of the gun, not withstand 50 atmospheres of pressure, will fail in sheer tension.
It creates a bizarre economic reality where a $150,000 portable missile system provided by NATO can consistently destroy a $4 million main battle tank, creating a return on investment that is catastrophic for the invader. Every time a turret pops, it represents not just a loss of hardware, but a loss of operational momentum, as replacement columns have to move slower and more cautiously, burning more fuel and exposing their logistics trucks to ambush. The jack-in-the-box isn't just a technical defect, it is a financial hemorrhage that bleeds the national treasury dry while simultaneously eroding the morale of every tanker who sees their friends get vaporized.
The mechanics of the explosion are so violent that we often find the gun barrel embedded in the earth like a lawn dart, 50 meters away from the chassis, serving as a grim tombstone for the failure of the design. The autoloader, which was supposed to be their greatest advantage in rate of fire, has become the primary mechanism of their destruction, proving that you cannot engineer your way around the danger of sitting on top of a powder keg.
The geopolitical aftermath of these turret tosses extends far beyond the Ukrainian mud, sending shockwaves through the global arms market and terrifying nations like India, Algeria, and Egypt, who purchased thousands of these T-90 platforms under the assumption they were buying world-class protection. We are seeing a massive cancellation of export contracts as foreign governments realize that their multi-billion-dollar armored fleets are essentially mobile coffins that can be decapitated by a drone, costing less than a used washing machine, destroying the reputation of the Russian defense industry for a generation.
Tactically, this widespread awareness has stalled their armored columns. Crews are choosing to abandon fully functional vehicles at the first sign of trouble rather than risk a critical breach when a tanker knows that a single hit can result in an immediate, total loss of the vehicle. The priority shifts to evacuating instantly. This leaves hundreds of intact units to be captured, repurposed, or simply towed away by locals.
This creates a demographic and economic crisis that is impossible to quantify on a balance sheet, because you are not just burning through steel, you are liquidating your country's future workforce and technical base. Every time a turret flies, 3 young men, mechanics, engineers, potential fathers, are removed from the economy forever, exacerbating Russia's already catastrophic population collapse and ensuring that even if they could afford to build new tanks, they won't have the people to operate them or the industrial capacity to maintain them.
From a survival perspective, if you find yourself buttoned up inside a T-72 or a T-64, your options are terrifyingly limited, because the design makes emergency egress nearly impossible once the hydraulic systems fail or the fire starts. In a Western tank, the crew has mere seconds to escape, but they have those seconds because the blast doors hold. In a Russian tank, you are effectively sitting inside the combustion chamber of a bomb, and your only real survival strategy is to not be inside the vehicle when the music stops.
We are now seeing the desperation in their logistics, with the appearance of Frankenstein tanks, ancient T-62s pulled from deep Siberian storage, lacking autoloaders entirely, or vehicles welded inside hideous metal sheds to stop drones. These modifications are the last gasp of a failed procurement strategy, a visual admission that the original engineering philosophy was flawed and that the state can no longer afford to provide real technological solutions to its soldiers.
The engineering verdict is absolute. The compact, low-profile design philosophy of the Cold War is officially obsolete in the era of precision top-attack munitions and loitering munitions. You cannot cheat physics by removing the human loader if the cost is placing the propellant charges in the most vulnerable coordinate of the vehicle's geometry. Mass and volume are necessary evils to provide the spacing and armor required to keep the crew alive.
And the financial verdict is equally damning. Attempting to win a modern war with quantity over quality works only until the opponent has a cheap, scalable way to destroy that quantity faster than you can produce it. Russia bet its entire doctrine on the idea that the tank was an expendable consumable, but they forgot that the trained crew inside is the most expensive and irreplaceable asset on the battlefield.
Future warfare will move toward active protection systems and unmanned ground vehicles, completely removing the crew from the hull because keeping 3 humans alive inside a steel box is becoming an engineering problem with no solution against hypersonic threats. Until then, the T-Series tank remains a cautionary tale of what happens when you prioritize aggressive geometry over human safety.
The bottom line is simple. A cheap tank is very expensive if it kills the crew every time it gets hit.
Stay sharp.
Check you 6.